If you're like me, you've always wondered why all the planets in the solar system are round. We see Earth as a bit squashed at the poles and swollen at the equator, but mostly round. And all the other planets are similarly round. But why? Okay, here's one good reason. It's called the science of shape. That sounds kind of lame, but it's really cool once you start thinking about it. There are two main forces acting on all the planets: gravity pulling everything down, and the rigid structure of the planet trying to keep it intact. Take Earth. Gravity pulls our planet into a sphere because it wants all the mass close to its center, where it can most easily pull it towards itself. But Earth isn't a liquid, so its gravity battle isn't over. Earth's rigid structure wants to keep the planet a bit wider at the equator, because as it spins, that wider diameter lets Earth's gravity battle gravity a bit more evenly. That means Earth ends up a bit squished at the poles and swollen at the equator. Most planets have this same basic shape, but there's another force at work too. As a planet rotates, it spins faster at the equator than it does at the poles. Faster spin means a bit of extra force pushing outward at the equator, fighting against gravity and making the planet a bit wider there. The faster a planet rotates, the wider it gets at the equator. Jupiter rotates super fast. Saturn is slower, so Jupiter is a bit wider at the equator than Saturn. But if gravity is what makes planets round, why aren't they perfect spheres? They are nearly perfect spheres, just not quite. One reason is that for something to be perfectly round, the gravity inside it has to be perfectly balanced. But gravity depends on mass, and mass isn't always evenly distributed. When you take Earth's gravity and stretch it out across the planet, it's a bit stronger near the poles because the ground underneath your feet is closer to the center of the planet and thus closer to where Earth's mass is concentrated. On the other hand, gravity is a bit weaker at the equator because Earth's mass is farther away from the equator than it is from the poles. This difference in gravity across the planet means that Earth's gravity isn't perfectly balanced, which is why it's not perfectly spherical. Another reason is that the stuff inside planets isn't perfectly evenly distributed. It's because some parts of planets are hotter than others. Hotter parts are less dense, and therefore have less gravity pulling them towards the center of the planet. Hotter parts also expand, taking up more space and making the planet a bit wider. So it turns out that hot and wide are pretty similar, which is probably why we haven't found any planets that are both hot and spherical. Let's do a quick review. To forces acting on a planet: gravity pulling everything towards the center and the structure of the planet fighting back, trying to make the planet expand. If gravity wins, you get something like Earth, a bit squashed at the poles and swollen at the equator. If the structure of the planet wins, you get something like Saturn's moon Titan, which is a bit wider at the equator than it is tall from pole to pole. Fun fact to add, planetary structure isn't the only thing that fights against gravity. Some planets have giant magnetic fields that fight against gravity too. Magnetic fields are generated by the movement of electrically charged particles, and on planets with giant magnetic fields, those particles gather around the planet's poles, creating giant magnetic bubbles that push outward against the planet. That adds to the equatorial bulge because it pushes against the planet sideways. Earth has a magnetic field, but it's small compared to the gravity force. But Jupiter's magnetic field is gigantic, so it's the dominant force at play. Jupiter is so big that gravity pulls hard towards its center, but its magnetic field is even stronger, so it wins the battle of the bulge. Jupiter's actually wider at the poles than it is at the equator. Okay, now let's think bigger. Could there be any planets that are totally dominated by their magnetic fields? Turns out there could be. If you took a planet like Jupiter, which has a huge magnetic field, and spun it way faster, its equatorial bulge would eventually become so big that its gravity would flip. The side of the planet facing away from the sun would collapse under its own gravity, and voila, you've got a new planet made of plasma. Scientists really think this happens. They've seen the collapsed plasma side of these planets, but no one knows exactly how fast a planet has to spin to make this happen because we've never watched it happen. It's really hard to study things that have never happened. So the next time you look up at the night sky, remember that while all the planets may seem pretty similar to us, they come in a whole lot of different shapes and sizes.